Let's consider an example where we have the summary statistics. So let's look at in the study plan for Chapter 20, question 83. And in this case, it says a golf tree manufacturer used a robot to hit balls off of their tee and a competitor's tee using the same club. So the idea is the robot is going to give a consistent strike force on the ball. And it says assume that 109 balls were hit off of each tee, and the data are suitable for inference. Is there evidence balls hit off the manufacturer's tee have a higher initial velocity? Okay, now looking at the table, you've got the competitor and the manufacturer. So the manufacturer is second, and you've got distance first, ball velocity second, and club velocity third. Now club velocity should be consistent because it's the robot swinging the club. The ball velocity is the speed or the velocity with which it is coming off of the tee, and this is what I really want to compare. So identify the null and alternative hypotheses. Well, M is manufacturer, C is competitor, and you want to see if the manufacturer has a larger mean. So when you take a larger number minus a smaller number, you should get a positive result if the first one is bigger. So that would be D. Compute the T statistics. So this is where I'm going to go to StatCrunch, and I'm going to plug in the velocity measures. So what I'm going to do is go under Stat, T statistics, to sample, and I have the summary information. So what I'm going to do is put in the information about the mean and standard deviation and stuff. So let me pull it down just a little more. And remember, I'm doing ball velocity. So the manufacturer's initial ball velocity average, 127.16. The standard deviation is 0.34. And they said assume 109 balls for each. Okay, so for the competitor, you have 125.35, a standard deviation of 0.52, and a sample size of 109. Okay, and I'll pull this back up. And then what we want is for the alternative, we want the difference with manufacturer minus competitor to be positive. So I've got to change that to greater than. And then click compute. And I'll pull this over where I can see it. So the T-stat is 30.416 when rounded to 3 digits after the decimal point. And then the p-value, round to 4 digits. Okay, so that's going to be less than 0.0001. And if it's asking to be rounded, I don't know if it'll take it within 0.01 or not. We'll see. Okay, so it did. And then, is there evidence the ball hit off the manufacturer's tee have a higher initial velocity? What's the correct answer? Well, with a p-value as small as it is, it's less than a 0.05 level of significance. So if I scroll back up, I am going to want to say that mu sub m minus mu sub c is greater than 0, which really is saying mu sub m is greater than mu sub c. Okay, so that's what I want to emphasize. Yes, there's sufficient evidence because the null hypothesis is not rejected. Well, that wouldn't make sense because if you don't reject the null, you can't prove the alternative. Yes, there's evidence because the null is rejected. Okay, so that's an example of where you have the summary statistics and how to do the T hypothesis test.